So hi everyone, myself is Sudhir. I was working on as a DevOps engineer, as designation as a principal engineer. So I've been working in this DevOps environment from past actually 7 years. So where I've been working on this DevOps culture and so here today we are going to completely discuss on the containerization level of deploying the applications. Okay. So not only that, actually, let me explain in the session actually what are the other topics we are going to discuss apart from the curriculum what you have got in the through the email or whatever it is. Okay, whatever the curriculum you have seen. Okay, so first of all, to start, actually, first of all, we have to understand few things. Let us start with that, and then we will go forward from there. Okay. So, so before going to the containerization level and understanding what is container and all, first of all, we have to understand what are the consequences we have in running the applications on the virtual machines. Okay, bare metal servers, everybody knows, right? What is the purpose of it? What we have done on that? Why we went to the hypervisor? And now we are going from hypervisor to the containerization level. Next level we don't know as of now, right? But now we are trying to migrate our applications from the virtual machine level to your containerization level. Okay, so that is where we are in the right now. The current stage is like we are trying to run our applications on the containerization level. Okay, so before going there, first of all, let us understand why we have to go there and applications like when you're trying to run some applications, what are the consequences you face? Okay, in the virtual machine. So the reason behind for migrating over there. So, as everybody knows, or who are completely new to this environment, I just want to know, like, everybody is from operations background, or do we have the people from testing background and development background, which they have never seen this operating system, Linux operating system? Any guys, or everybody has experience on operations, like Linux operating system handling it, it's some administrative task and all. Some idea. You can unmute and you can speak out actually. If you are not familiar with Linux operating system.
Yes, here, this is Narendra. So I'm pretty much new to this Linux and shell scripting background. But
Okay.
I know I'm from network infrastructure side. The OS platforms that are speaking about the Linux or Unix flavors, it's quite new for me. I've
Okay.
been with networking iOS platforms like Cisco type of things.
Okay, okay, copy. Yeah. Anyone else?
Yeah, myself is Srinivas from DBA background and
Okay. So database administration, right?
Hi,
Okay.
Sudhir. This is Deepak. I'm from Automation Industry.
Hello, myself Chandrasekhar. So I am currently working on DevOps, but I
Okay.
would like to know more Docker and Kubernetes and deep dive. So that's what I
Right.
joined. I have
Understand.
very basic Linux experience, but not in admin level. I can write shell
But at
scripting,
least,
but
yeah,
yes,
at least you handle the operating system, right? Logging in, doing
right, right,
something.
yes,
That is enough. That's what
yes.
I'm trying to understand actually. If someone who has not at all logged into the Linux operating system till now, so that's where I want to know.
Hi, this is Nikhil.
Okay.
Hello. Yeah, I'm currently working on Oracle projects, Oracle Rise technology. So just
Yeah.
want to know, started with Azure training on fundamentals. So just wanted to know what is uh, Docker and the Kubernetes pipeline. So I've just joined this session. So how can I
Okay.
start with the things? Is it like if you are involved in projects, then only we'll get to know about this, or we can have separately? We can learn just on our own without any without doing the projects as well.
Yeah, let me tell you that. So end of the session, I will. You can ask the question after this. Okay. If you are not
Sure, sure.
your questions are not answered, you can just ask me. Okay.
Okay, okay, sure, Sudhir. Yeah, thank you.
So yeah, now what I understood is like, anyways, to be frank, actually, we will be starting from scratch, not the administrative level of Linux operating system. So what I will be starting with is nothing but how to run your operating system. Okay, Linux operating system like Ubuntu or CentOS, whatever we do. So those operating systems I will be showing from scratch. Means creating a virtual machine, where to create, what is a platform. Let's say you don't have a laptop that has a minimum configuration where you cannot run a virtual machines. Okay, then the simple thing is like we can get a GCP account for 3 months of free. Okay, and then you can use it for 3 months, right? So they will give you some 22,000 of INR, and until that is completed or the three comes, which comes first. So until then, you can use that particular GCP account. So for us, it is not needed to bother about the resources. We have so many ways to uh, practice the sections, whatever we are going to learn in this particular entire course. Okay, so that we can see later. But here, so first of all, I will be starting with Linux operating system installation, configuration, and then networking part. Why? Because why networking part? Because nowadays, whether you are a DevOps engineer or the person who is working on any platform right now, he has to understand the core concepts of networking. I'm not talking about the Cisco level networking and all. At least when a system is given to you, you have to be in a position to understand the basic networking on how to configure that. Okay, and you have to understand few things about the underlying networking, how the data centers or the infrastructure is working on. Okay, so that's where we are trying to learn in that particular perspective as well. So you have to be in a position when you give a system to you, not only installing the operating system, you have to configure the networking as well. So we have to understand the basic networking like what is CIDR, what is subnet, what is classes, okay, what is layer 4 or layer 3, layer 2, okay. So and then we have to understand how to calculate the IP address when a CIDR is given to you. What is a network host? What are the network bits and what are the host bits? So based on that only you will decide like how many systems can be connected to a network, right? So these things we have to learn. So once the operating system is done, installation and configuration, then I will be jumping into networking. Okay, so this is purely on like how to calculate the IP address, how to assign the IP address, what is bridge, what is NAT, okay, what is host only. Okay, so which type of networking we have to use for our setup. Okay, so everything we are going to see in this particular second topic what we are going to discuss like networking. And then actually I will be jumping into Docker and Kubernetes. Okay, so that's how it goes. So no need to worry if you are completely new to this particular operating system and all. Anyway, we are starting from scratch. You'll get some time to learn. So I'll be sharing all the documents, whatever it is needed to practice. And apart from that, I will be showing you practically like how to, what are the things you need to follow for this Docker and Kubernetes session. Okay. So let's try to understand the history, like or the things why we have jumped from hypervisor to the containerization technology. Okay, so that everybody knows that earlier we used to use the bare metal servers in order to deploy our application, right? So that is where we have started our operations, right? So we used to deploy some application on the bare metal server, one or more applications of a different functionality we used to run on that particular hardware, right? So after that, the problem is, let's say in the testing stage or there is a situation where I want to run the same application and I want to do some bug fixes and I want to do some particular upgrades and all. So in production server you cannot do that, right? But testing cannot be done, so you need to get the same replicated server configurations and all, and then you have to do it. So it is a cost effective, it is costly, and you have to maintain it, and there are so many other factors which will involve in this. So that's the reason we got a concept called simple. I'm putting it in a simple words. Okay. So then we got a concept called hypervisor. So a hypervisor is a piece of code actually. Okay. It's a piece of code where it will try to run virtual machines on top of your physical hardware. Means on your bare metal server. So let's say you have a rack server, bare metal, Dell server or HP server, whatever it is. When you use it, IBM servers or whatever it is, so when you take that particular bare metal server and you will install the hypervisor and then you will run the virtual machines. So virtual in the sense which is not physically exist. Okay, it's not a physical resource. It is a machine which is created through software. So that's the reason it is called as a virtual machine. Okay, a machine which is created through software is called as a virtual machine. What is that software? It is called as hypervisor. So here we have two types of hypervisors. One is hardware hypervisor and one is software hypervisor. So type 1 is called as hardware hypervisor. Type 2 is called as software hypervisor. So hardware hypervisor in the sense where you don't install any operating system like Linux or Windows, you don't install. Your hypervisor itself is a software. No, it itself is an operating system. Okay. So let's say for example VMware ESXi, Hyper-V, Zen. So these are the type 1 hypervisors where you will take a bare metal server, you will install the hypervisor and then you will run the virtual machine. Simple. Okay. So it is called as type 1 hypervisor. Okay. There is a next type of hypervisor which is called a software hypervisor. So the software hypervisor is nothing but you will have a hardware like your bare metal server, then you will install the operating system, okay, and then you will install your hypervisor. For example, Oracle VirtualBox, okay, VMware Workstation, okay, these are the tools, right? KVM. So these are the tools which cannot run without operating system. Okay, these hypervisors cannot work or cannot function without having an operating system. Okay, if I give you a bare metal server and if you try to install VMware Workstation, it's not possible. Okay, and Oracle VirtualBox is also not possible. You need an operating system to run them. It is called as software hypervisor. So whatever the hypervisor you are using underlying, ultimately you are trying to create a virtual machine. Okay, so I hope this concept is clear, right? So virtual machine in the sense now your RAM which is attached to your virtual machine is not physical, it is a virtual, means some amount of RAM is allocated to your virtual machine. Okay, similar to CPU, which is called as vCPU, virtual CPU, virtual memory, virtual hard disk. So everything is virtual. Whatever it is used by your operating system virtual machine, it is called as a virtual devices. Okay, whatever it is, virtual resources, whatever we call. Okay, now this is fine. Why? Because on a bare metal server I can create a number of, depends upon the type of resource you have on your bare metal server, it depends how many virtual machines we can create. Now with this, what is advantage for me, it is not needed to purchase any other physical bare metal server, right? So I can create one more virtual machine, I can replicate the same thing by cloning the virtual machine or doing some other thing. Okay, I can replicate one more virtual machine and I can do some testing and then I can apply it to the virtual machine, sorry, the production VM. So this is simplifying my job. It is not cost effective. Within the resource itself, I am doing this. So this is the advantage which you get it from the hypervisor, whether it's a software or hardware hypervisor. This is what we try to do generally. Okay. Now, so these are the basic things. What is a virtual machine and how it runs actually. Okay. So now why we are going to the containerization level? We are happy with virtual machines, right? So why we have to go with the containerized applications? Okay, not in the virtual machine. So let us discuss few points. Okay. So now let me tell you some disadvantages when you run your application on the virtual machine. Okay. Let's say you have some application running in virtual machine app A. Okay. So it will have its own operating system. Okay. Forget about the base operating system, means the operating system which is running on your bare metal server. Okay. So that is called as host operating system. The operating system which is running in your virtual machine is called as guest operating system. Okay, so do remember these technical points. Okay, most of the people know, but again we are trying to repeat it. Yeah, guest operating system and the host operating system. So when you're trying to run a virtual machine with an application, so forget about the application. When you try to run a virtual machine, what is the important thing to run your applications, or to what is the main thing that you run your Linux operating system? Kernel, right? So kernel is the main heart of your operating system, Linux operating system. What does it do exactly? So have as a human readable, as I am a human being, right? I want to interact to the devices. So whether it is a CPU, whether it is a memory, whether it is a store hard disk, or whether it is other devices, I need to communicate to them and fetch some information. So my devices can understand only binary language, zeros and ones. Okay, only it can understand zeros and ones. As a human being, I cannot understand that, right? I need some additional skills or some skills to understand this binary language. So I cannot jump into that, right? Everybody cannot do that. Okay, so that is not my job. So as a human being, I have to pass some information as I know. What are the language I know? I'll be typing that. So that information will be given to the operating system. Operating system will take it and will give it to the kernel, and kernel will give it to the underlying hardware. Okay, it will convert into a binary language, and that will be given to your hardware, and the hardware will respond to it. It will be given back to the kernel, and kernel will run some system calls, and that will be given back to your operating system terminal or GUI, whatever it is, and the information will be displayed. Okay, so this is the purpose of your kernel, right? So that is the intention of using it. Now, so here comes the actual factor. So when you want to run your operating system, actually it will run a lot of services in the background, right? Even when you run your Windows operating system, when you boot up, it will run so many services in the background, right? So similar to that in Linux operating system also, when you boot up your operating system, actually there will be a lot of services. Forget about application services. I'm only talking about operating system related services. So when you run your virtual machine, there will be so many services running in the background, right? So these services will occupy some amount of CPU and memory and storage as well. So which is already occupied. Let's say I allocated 4 GB of RAM to you and 50 GB of hard disk to the virtual machine and one core CPU. So some amount will be already used by your operating system. Only the left amount will be used by your application. So that is the first problem which we have. You understand the problem, right? Whatever I've told. See, when you run your operating system, there will be some services running in the background. To run that particular services, the process which we call, it needs some CPU and memory and the storage as well. So some amount is already occupied by your operating system services, and the left amount of resources will be occupied by your application. I don't want that particular thing to be happen. Whatever the resource is allocated to my virtual machine, entire thing should be used by your application. Is that possible? No. Why? Because operating system should be there for a virtual machine. Without that, you cannot allocate the entire resources to your virtual machine, right? So that is the first major thing which we have. Alright. Okay. So do you agree with me, or anyone has some questions?
It's also clear.
Yeah. So now this is the first problem what we have. Next problem is nothing but, let's say I allocated some amount of RAM from the base machine. Let's say I'm totally running this, the app 1, app B, and app C. Okay. Let's say my base machine is having 16 GB of RAM. Okay. So now I have allocated some 4 GB, 16 GB of RAM. I allocated 4 GB, 4 GB, 4 GB to this. Okay. So it is total 12 GB, and 4 GB is left for your base operating system to run. Why? Because without having RAM, you cannot run your operating systems. If operating system is not running, your virtual machines cannot run, right? So it needs some amount of memory to run them. Okay. So once you understood that, yeah. So I allocated 4 GB RAM to this particular virtual machine. Now I am running some application. That amount of RAM is enough to run your operating system and your application. Fine, good. Now, due to publicity and all, users started accessing my application. So the number of requests got increased for my application. So there is some amount of load added to my application. Automatically, it will increase the utilization of CPU and memory, right? So the amount of CPU and memory which I allocated to my virtual machine, now it is not sufficient. Why? Because so many users started using my application, and because of that, the load got increased, right? So now what I have to do now, is there any other choice? I have to shut down my VM, and again I have to increase the resources, and again I have to run my virtual machine. So anyway, these things we will do in non-business hours, but we have to do this, right? And let's say after a few months or few years, the customers got reduced. Maybe one or two customers are using my application. For that, whatever the amount of memory and CPU which I increased is not at all useful. Unnecessarily, I have allocated right now. Because of that, other VMs are getting affected. So they don't have enough resources to use. So what I want to do, I want to reduce from this VM, and I want to allocate to this VM. Okay, so these are the things which we have to monitor and which we have to do manually on the virtual machine. Okay, so this is the second problem what we have. Okay, so these are the two major things why we are trying to move to the containerization level, and what are the advantages we have with the disadvantages what we have in the virtual machine. Okay, so that is what I have to. I just took only two examples to suffice this summary. Okay, now these are the two drawbacks which we have, right? So let us come to the containerization level. First of all, let us understand what is a containerization, and then we will talk about the disadvantages in virtual machine, how it comes an advantage to your containerization. Okay, so the containers in the sense, if you want to create a containers, there are so many tools for us. Okay, we have, you understand the history. Before Docker came into picture, we have some other tools for Linux operating system to create the containers. Does anyone know about it? We have a tools to create a containers before Docker came into picture. Any guess?
No idea, Steve.
LXD and LXC. Have you heard about it? LXD and LXC. Linux containers and Linux daemon. So these are
The
the
Linux
tools.
containers we had actually, but we had
Yes, right?
I just heard of it. That's it.
Yeah. You might have heard somewhere. That's what I'm saying. You might have heard somewhere, some blogs or some particular concept somewhere. You might have heard it, right? So these concepts are there before your Docker came into picture. Okay. Why it not became more popular? Because the first and foremost thing is nothing but it is especially only for Linux operating system, right? But your Docker is a cross-platform. You can run your Docker on one Windows as a desktop, on Mac as a desktop, and your Linux system as a server, right? So these are the things which Docker provides. Whereas LXC, it is only specific for Linux operating systems. Okay, that is the first thing. And the next thing is nothing but LXC doesn't provide you so many functionalities what Docker is providing. So that's a reason like image build, the other things what we have, right? So it doesn't provide you that flexibility in the LXC or LXC. So that's the reason Docker became more popular. Then the people came to know that we have a containerization technology. We can run our applications on the container. And this is where it came into picture actually. So, to be frank, actually, Docker itself is not creating a container. It's not the tool which is actually creating a container. Docker is a platform where it will use some other technologies in the background, which is already existing Linux operating system, Linux or any operating system, and then it will take the advantage of that, and then it will create a containers file. Okay, so Docker is a platform where it was created to run your containers. Okay, in the background, Docker is using so many other tools. I will tell you in depth in the actual sessions, but right now understand that Docker itself is not creating a container. Docker is using so many other tools in the background, okay, to create this containers. Okay, now what is a container? So container doesn't have any operating system. That is the first thing. If someone asks you what is a container in it, container is a simple process running on your machine. Simple process. How you run your normal application, right? When you run your application, it will create a process ID, right? So similar to that, when you try to run a container, it will create a process ID for that container. Simple. Okay. And that is the first point. Second point is nothing but it doesn't have any kernel. Okay, so your containers will try to interact to your base operating system for hardware related information. Okay, if it is needs some memory, or if it needs some CPU, or if it needs some storage, it will communicate through the Docker or any other tool, and then through the host operating system. Okay, so this is the second thing. So these are the major things what a container is. Container is a simple another process which runs on your machine. How you run your application on your bare metal server, right? You, if you run your database, that will create a one process ID. If you run web server on the same bare metal server, it create another process ID for that particular web application. So similar to that, if you try to run your container, it will create one process ID for one container. For another container, it will create another process ID. So how these two process IDs isolate with each other based on namespaces. You can see the point over here, kernel namespaces and cgroups. Because of this advantage, your one process ID cannot communicate to the other process ID which is present on the same machine. Okay, which is called as isolation. Isolation in the sense, this is not communicated, so this is not merged into that particular process. Okay, so these are the advantages what we have when you try to run your container. Okay, now
Hello.
this is what the
Yeah.
container is. Yeah.
Hello.
Yeah.
Yeah. Let me. In one container, how many application we can run?
Only one application to be run. Only one application.
Only,
That is what it
only
is
one.
recommended. Yeah. Yeah.
Okay.
Yeah,
Simple. Assume
one
that
more thing.
one process ID can handle only one application. Sorry, one application can handle only one process ID, right? Under that, it has a child process IDs that belongs to the same application. So similar to that, in a container, you have to run only one process. If you run two different applications, then again the concept is breakdown. Why we are using containers? To run your own application, right? There should not be any other process running in my container so that it will occupy the resource which is allocated to me. You understand?
Yeah.
One more doubt,
Okay.
sir. Can I?
Yeah. Yeah.
Yeah, come like let's take an example of like Angular only for deployment. I use containers, but does there any limitation from the Angular applications or any applications that's not considered Angular?
Limitation in the
Because
sense if it needs physical hardware, there is. Let me tell you, whatever the host operating system is using the kernel, every container will use the same kernel, right? So because it
yeah,
doesn't have any operating system or a kernel with a different version, right? If your application needs a specific kernel, then you cannot run in a container. So it should be run as a virtual machine only. Your application to be run in the virtual machine. Why? Because your virtual machine will have its own operating system with its own kernel, right?
yeah.
So for those kind of applications, you have to use a virtual machine. There is no other choice for us as of now. Okay.
But if I'm using microservices, I can create multiple containers. That's
Of
true, right?
course. Yeah.
Wait,
Microservices are nothing but again the process ID is divided into multiple chunks actually. The application is divided into multiple chunks. That is called as microservices to be simplified.
yeah,
Okay. Whatever it is, microservices or the containers are the same concept. Nothing will have a kernel, so they will not have any operating system. They will run. See, then what it has, how it is running your application. Does anyone know? For an
uh,
application to run, what is needed?
main the kernel and OS, main OS.
But I
Kernel
don't have any
memory
kernel,
and
right? Okay. Coming to the point, the container doesn't have any kernel. Then
it uses the host system kernel, right?
host. Oh, sorry. Come again. Host operating system. That's fine. That is fine. Okay. If it needs some memory or it needs some CPU or some particular storage, it will go to the host operating system and it will use it. That's fine for me. Then how is an application running in your see it needs something, right? Libraries and binaries,
It
right?
provides application services
Docker
for
image.
See, for every application to run, it needs some libraries and binaries. Without having that, it cannot run it, right? Though you have a memory, what you will load in the memory? There should be some particular things running, right? So every operating system or any application to run, every operating system will have some libraries and binaries. For example, in Windows, we have a program files directory, right, which will be running in C drive. Okay, so that program files will have all the libraries and binaries to run your operating system. And if you install a new application, those libraries and binaries also will go into that particular directory. So similar to that, if you try to compare with your Linux operating system, Linux operating system will have a root file system, which is called as forward slash. Not like a Windows, it's a program files directory. Here it is called as a forward slash root directory, right? So under that you will have all the directories which will store the libraries and binaries and other things as well. Okay, so those things will be there in the container. Okay, so the container will have all the root file system related libraries and binaries to run your application. Okay. So with the help of that, it will take the libraries and binaries of that particular operating system. While running the application, it will go to the RAM and it will load it. Okay. So that's how it happens. So container doesn't have any kernel. It will have only operating system related libraries and binaries. So that is what you
Yes, so
have
then
to
you
say.
mean to say each container would have its own directories, which would carry
Yes.
the like binaries and libraries.
Yeah, that's what, right? See, if I run a CentOS container, it will have CentOS container, CentOS related libraries and binaries. I cannot run Ubuntu related binaries over there, right?
Yep, yep.
Okay, so simple as it is. I can run any sort of containers over here. It doesn't bother about, see, it doesn't depends upon your host operating system. The only one thing is nothing but if you are running your Docker container, Docker tool on your Windows operating system, sorry, on Linux operating system, you cannot run Windows container on your Linux if it is your base operating system is Linux. Okay, if you have installed your Docker on Linux operating system and if you want to create a Windows container, it's not possible as of now. Okay, but on Windows it is
Well,
possible. You can create a Linux containers
y-
as well as Windows containers.
yeah, Sudhir, is it possible to, run container inside one container?
No, 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 it is not.
Okay.
You cannot.
Sudhir, how does
Yeah,
Actually,
Sudhir,
there
sorry
are
to interrupt you.
images, right?
Actually, we
interpretation
have
side?
discussed, right?
Sorry, sir, one by one.
So in virtual machines, for every application, it would have separate RAM, separate CPU, everything,
Yes,
right? So if
yes,
multiple users are getting connected, the RAM
yeah,
has to be increased based on the load, right?
obviously,
So even
obviously.
in future also there won't be much users. We have discussed that, right?
Yeah,
So
yeah.
that's scale in and scale out. So with respect
Yeah,
to the
that's what
resources,
I'm about to talk that particular points actually. I told you two disadvantages in the virtual machines, right? I will tell you what are the advantage, how it is advantage, like how it is creating
yeah,
an
how it's going
advantages
to
in the
be
container.
handled in Dhaka. That's what my question is.
Yeah. Yeah. So let's say your container when it is created, it will use only how much amount of RAM and how much amount of CPU is needed. Only that amount will be used. Based on the requirement of the application, it will start increasing dynamically. Okay, it will send a request to your host operating system using the Docker, and then it will increase dynamically. When it is not needed, it will decrease dynamically. So this is the advantage what you get in the containerization tool. Okay.
Answers my question. Sudhir.
Yeah.
Sudhir, what kind of interpreter does the application use? Like kernel
Sorry.
interpreter, host kernel. What kind of interpreter does the
Host
application
kernel.
use? Host kernel only,
Host
right?
kernel. Yeah.
Okay, host kernel
So
will
when you your application will send a call to the Docker. Docker will send a call to your operating system. Operating
mhm.
system kernel will use some system calls to talk to your physical hardware. Okay.
Okay, okay. Thank you.
Any questions? No. Okay. Now, when your container doesn't have any operating system, so what are the resources allocated to that particular container is entirely used by your application itself. So this is the second advantage what we have in the containerization tool. There are so many other advantages. I took only two comparisons between your virtual machines and containers. One is like there is no need to worry about dynamic allocation of your hardware. And the other thing is nothing but what are the resources used by your container is entirely used by your application. Why? Because it is just a process. Okay, simple. Whatever the resources allocated to your process is used by your only your process ID. Nothing else is used. Okay, so that's the reason we should not run two applications on the same container. Again, you are crossing the limitations of your container, the advantages of the container. Okay, simple. It doesn't mean that you cannot run, but it is not the appropriate way to run. Okay. So this is how the containers takes advantages. So we will go in depth. Actually, it's not that easy to understand the containerizations, how it is created and all, because I will tell you there is a concept called kernel namespaces and C groups. So if you want to be strong enough in this particular technology, you have to understand what is the underlying technologies as well. Okay, how Docker is functioning. Because I will tell you what I will show you one slide. Okay, so this is the points which we have already discussed. I'll show you one slide. Okay. So this is the high level picture of how the Docker is working. Okay. So there are three things which you can see: client, host, and registry, right? So when you run some CLI command, that CLI command, see, let's say you have installed Docker on a Linux operating system. Okay. So there will be a CLI package and there will be a server package, right? The CLI package is called as Docker client, which you use. Okay. The server package is called as Docker host, where your daemon will be running. Registry is something where the images will be stored. I will tell you what is that exactly. Okay. So when you run some CLI command, that CLI command will pass some API call to the daemon. Okay. So how it will reach, it will is a secondary thing. But the API call will reach to the daemon. Once a daemon has received the information based on the things which you have provided, if the image is not already there in your system, it will download the image and then it will from the registry and then it will create a container for us. So what is the image? Image is nothing but your like a ISO. See, to create a virtual machine, to install the operating system, we need a ISO, right? On the bare metal server or a virtual machine. Similar to that, in order to create a container, we need an image. So image will have all the libraries and binaries of that particular operating system. Okay. So we get some official images from the CentOS repository and Ubuntu repository as well. Okay, we can use it and we can do the changes actually. So we can customize the images, we can build our own images, and we can store it in the registry. Now AWS is providing a registry, GCP, Google Cloud is providing a registry to store the images and all. So we can use whichever platform we want. We have third-party registries as well, like JFrog, other registries, GitLab. So there are other registries as well to store the images. So Docker itself is providing its own registry, which is called as Docker Hub. Okay, so this registry, whatever you are seeing, by default, it will search for the Docker Hub. So Docker Hub is a repository where all the images will be stored, official images and third-party images as well. So Docker daemon will see whether the image is there in your system or not. If the image is not there, it will go to the registry, it will download the image and it will store in your system. Once the image is there, then only it will create a container. So with this single image, we can create n number of containers. Okay, it doesn't mean that it only one container can be created from one image. It's not like that. We can create n number of containers. Like how we can use a single ISO, bootable ISO, to install on multiple machines, right? Similar to that. Okay. So this is how it is. If you want to see this particular thing, Docker Hub registry, I'll show you the Docker Hub official report. Okay. Let me show you. Let's say I want to create a MySQL container, okay, database container. So this is the repository. If you want, you can create your own account and you can store your own images and all. But this particular thing is maintained by your Docker team. Okay. So now let's say I want to search for MySQL. Just execute MySQL. You can see there is so many images with MariaDB, Percona, PHP MySQL, MySQL Server Enterprise Edition by Oracle. Okay, we have other things. These are third parties. Okay. So now how you'll come to know which is an official image? Official image in the sense what? The image which is developed by their own team. See, MySQL itself has developed their own image, Docker image. Okay, the container image actually. So that thing you can see a tag called official image. Okay, I want to create a MySQL container. So you have to use this particular official image to create a container. So if I click on that, it will show you what is the command you have to execute in order to pull this image to your local system. So in order to pull the image from this registry to your local system, see, without having image in your local system, you cannot create a container. So first you have to pull the image and then after that it will create a container. So to do that, we have to execute this command to pull the image from this repository. Okay. So this is one of the repositories. So similar to that, we have some third-party repositories, public repositories and all, where you can store the images. Okay, that's a simple thing. So now, so this is a high-level view. Now, if you want to understand what Docker is exactly doing to create a containers once the image is downloaded, for that I have another slide, which is a bit complex, but this is one of the interview question where people will ask actually. Okay, if they want to ask in depth of what is happening in the container creation, so you have to tell about this. Okay, so here is a high level view. You are telling that CLI command is executed, daemon is calling that particular API call, and then it is downloading the image, and then it will create a container. This is a simple way of explaining it. But if you want to go in depth, so this is what you have to tell. When you execute a CLI command, you can see here CLI is used to execute a command that we already know, right? We have a dashboard for Docker as well, which is called as port trainer. Whether you do from dashboard or whether you do from CLI, there is an appropriate API call which will be loaded. Okay, so that API call will be reached to the daemon. So daemon will receive the instructions what they want to do. So from the CLI, as a user, I'll tell what I want to do. So that will be received by your Docker daemon through the API call, right? So once it is received, Docker daemon calls container D to start a new container. So which means that let's say I want to create a container. So as I told you before, Docker itself is not creating a container. So Docker is using a tool called container D. So if you want to really see that, what is that exactly? Let me show that as well, so that you will understand whether it is okay. So this is the actual code which will be used to create a container. Container D is actual platform, actual tool which will create a containers for us. So Docker is using, I told you right, Docker is a platform, okay, which is providing you all the functionalities together in the backend. So similar to that, container D is one of the functionality where Docker is using to create a containers. Okay, so just remember that. So now, so once the container D is received the information from the Docker daemon, okay. So how it will pass the information from the Docker daemon to the container D? I have to pass the information, right? how will you pass? That is called as gRPC call. Okay, Golang CRUD style of API call it is called as, but it is called as gRPC call, remote procedure calls. Okay, it is a kind of language where it will be used in order to pass the information from one tool to another tool. So from the Docker daemon, it will pass it will carry the information and it will give it to the container D. Okay, so once a container D has received the information, I told you in the previous slide, right? If the image is not there, it will download the image. If the volume is, if some other prerequisites are not there, it will try to do that first. Okay, so those things will be done by your container D, and container D will it will bunch all of them together, and it will create a OCI bundle. Okay, from the Docker image, it will try to create a OCI bundle. So that OCI bundle will be given to the container to create, actually that OCI bundle which is created by your container D, that OCI bundle will be given to the runc, which is called as runtime interface. Okay, so you can also see that actually. Let me show you that, because these are the tools actually. Just I want to show you that these are the things which are used in the backend. So this is called as container runtime interface. Okay, you can see here runtime, container runtime. So we can just read this official document, you will understand that. But anyway, let me tell you what is that exactly. So this OCI bundle is given to the runc. Now the runc is the actual component. It will take the advantage. I told you, right? It is using namespaces, C groups and all, which is there already. These functionalities are already there in the Linux operating system. Okay. So your runc will talk to that particular namespaces, C groups and all. Then it will create a container for you. Okay. With all the information what it is gathered through OCI bundle. So this particular runc is the actual component who will create a container for us. Once a container is created, it will start the container as a process ID, child process ID under the Docker process. Okay, and then once it is exited, it will start the container. Once a runc is exited, it will start the container, and that container information will be shown in the terminal. That's it. Okay, so this is the whole. See, now itself you will not get it based on the practice, or when you see it practically, you will understand. Okay, but this is what actually happening in the background when you try to create a container using Docker. Okay, so that is a fun thing. So yeah, any questions? This is the whole picture, like how the containers are created in the actual environment. Okay, does anyone heard that Kubernetes is deprecating Docker support? Does anyone heard about it? Kubernetes?
Yes.
Yeah.
Yeah,
So
Kubernetes have.
okay. By understanding this, can you tell me what could be the reason?
It's about the server management. Like when you have applications with Kubernetes,
Can you repeat the question, please? I didn't get you
Okay.
exactly.
So Kubernetes has so many, Kubernetes supports. See, Kubernetes itself is not creating a containers again. Either it should use Docker, or it should use a container D, or it should use a CRI-O, some other container runtime interface is CRI. It should use some other container runtime interface plugin in order to create a containers. Okay. So from 1.22, now currently Kubernetes latest version is 1.21. Okay, from 1.22, Docker support is getting deprecated. It's completely removed. It will be removed. The support will be removed by Kubernetes open source team. Okay, so what could be the reason? After understanding this concept of creating the containers, why they have removed a support for Docker? The reason behind is Docker is also using containerd to create a container, right? So when your Kubernetes is passing the information to the Docker and Docker to the containerd, there will be some latency, right? There will be some latency, obviously, where it is an API call, whether it is a socket or whatever it is having some latency. Instead of that, if your Kubernetes is directly communicating to the containerd to create a containers, obviously the latency got reduced, right? So that is a major thing why they have removed Docker support. Okay, and Kubernetes wants only a container creation. It doesn't need any other functionality what Docker is providing for us. I don't want that for my Kubernetes. I just want Docker to be creating a containers. So when I want only that particular, can you go on mute actually? Hello.
Yeah.
Can you go on mute? I think there is a noise from you again.
Yeah, yeah. Okay, done. So what I want to say is, even your Docker is using container D to create a containers. Okay. And I don't want what Docker is providing some other features like volumes, networking and all. I don't want. Why? Because Kubernetes has its own volumes and Kubernetes has its own networking concept. So when you have its own inbuilt features, why I want to use a Docker? So Docker is also relying on container D to create a containers. So why can't a Kubernetes use directly a container D to interact and create a containers for us? So that is advantage. Okay. So that is the reason why Kubernetes has stopped support for Docker from 1.22. Okay. That is the reason behind. If someone asks you,
Sudhir,
you
I
can
had a
explain.
question.
Yeah.
Actually, container D also is software, and it is by default comes with operating system, or we are going to
No,
install.
you have to install. You have to install. It's you have to do
Okay.
it. Right
Okay,
now,
but
it is not
actually,
supported by operating system. Maybe in future they will try to install it. I'm not sure about it right now, but maybe in future.
But if you
okay.
install Docker, CLI and Docker daemon, it will come by default.
Yeah, yeah. See, when you install Docker package, obviously you'll get all these things. Okay. So
Maybe
these
say
are the
even
basics,
this
guys. Yeah, go ahead. Sorry,
Docker D can be installed separately also.
not container D.
Sorry, container D. Sorry.
And one more point, client can be installed on one machine, Docker host can be installed on another machine as well. Okay. So these are the concepts which I will give you as a task actually. Okay. So we can discuss in the actual sessions. So not only Docker engine, say guys, whatever the Docker concept which I told you now, it is called as Docker engine. Okay. So it is called as Docker engine. Okay. So these are the concepts which we have. Okay. In the Docker. So Docker daemon, Docker client, Docker registry, Docker objects. The underlying technologies for Docker are namespaces, C groups, union file system, and container format. Okay. So these are the underlying technologies of Docker, how it's creating a container. Okay. Sorry. So you have to understand what is namespace, what is C group, what is union file system, when we have to use which, okay, what is a container format, we have to understand this. Now the time slot is not sufficient for us to explain all these things, but in the actual sessions, we will be going in depth of it actually. It's not that only we will be talking about containers, creating a container, running an application, it's not like that actually. So we have to understand the core concept of how it's working actually. So when you are strong enough, see, that's what I believe. So when you are good, when you have good understanding of underlying technology of any tool, so that will be giving you some boost up for your career as well. So that will give you some separate identity from others. Okay. So that's it. And you will be strong enough in understanding the underlying technologies as well. Okay. How it is built. See, in AWS, does anyone know what is happening in the background? How that functionality is working? No, right? Until you are working in AWS core team, you will not know it. Okay. So that's what I tell. So that's the reason why I have not choose AWS Kubernetes service or Azure Kubernetes service or GCP Kubernetes service is because that will simplify my job. But the problem is you will never know the underlying technology. So that's the reason I have chosen this. Everything, whatever we do, we will do on premises. On premises in the sense, technical term, everything you will install from scratch on your system itself. Okay. We are not using any cloud provider. Okay. We will be using our own systems to practice our underlying technology and deploy the applications. Okay. I'll be showing some complex applications, how to deploy, how to manage it, how to build our own custom images, complex images, and how to create our own container and all. That I'll be going to discuss. Okay. Once these concepts are done in Docker, in Docker engine, which I'm actually talking about, creating containers and all. Other concepts are nothing but Docker Machine, Docker Compose, and Docker Swarm. These are the other three tools which we have in Docker, which is provided by Docker, but these are low priority. It is not mandatory, but Docker Compose is important for us. Okay. So I'll be concentrating high level on Docker Engine, low level on Docker Compose. Docker Machine and Docker Swarm actually can be ignored. But I will give you some picture on that. What is Docker Machine? Actually, Docker Machine itself is negligible. Docker Machine, I will give you some picture. What is that exactly? Why we are not using Docker Swarm when Kubernetes came into picture? Okay, actually Docker Swarm is not used. Why? Because Kubernetes came into picture with new functionalities what Docker Swarm is not providing. Okay, so that's what I want to explain in that. Okay, once that is done, Docker itself is having a GUI tool where if you want to manage your tenants, users, okay, creating a separate permissions and all manage. See, everybody should not log into my Docker machine and create a containers. I don't want to give them physical access to my machine. Instead of that, you can install a tool like this and create a dashboard GUI to create a container. See, let's say I want to create a user. For that user, he should create only containers. He should not delete a container. He should only create a container. So if I want that particular functionality, I have to use a dashboard like this. If I give a CLI access, what will happen? If he logs into my container, sorry, Docker host machine, he can do whatever he wants. He can create a container, he can delete other containers, he can delete its own container as well. I don't want to give that particular functionality. So for those cases, we can give the GUI access. Okay. First of all, you have to install it, and then you need to give the access. Okay. So it is an enterprise edition. For free license, I will tell you what is the changes between free license and enterprise edition. Okay. And once it is done, I'll be explaining about Docker Swarm and Kubernetes orchestration. Kubernetes is an orchestration tool actually. So I'll show you the differences between them practically. And before jumping into Kubernetes, we have to understand what is a YAML. Okay. So what is a YAML? How to write a YAML file? It's not a programming language. It's a simple way of writing the data into a file in a proper format. Okay, it's a way of storing the data in the file in a different format, whether it is a JSON or whether it is a YAML. Both are does the same thing. You are storing the information in the file in a proper format. That is called as a JSON and YAML. Okay, so we will understand how to write a YAML file and JSON file. Why? Because when you work with Kubernetes or a Docker Compose, you have to everything you will be writing in a YAML format. Okay. So this is the actual Kubernetes architecture. Once the Kubernetes concepts are done, I'll be showing the dashboard how to install the Kubernetes dashboard to manage everything. How you do for Docker, right? Similar to that. Okay, Kubernetes cluster. Then we will be once this concept is done, we will be installing monitoring tools as well, ELK, Elasticsearch, Fluentd, and Kibana, and Grafana as well. And we'll be installing Prometheus as well. So these are the three different monitoring tools which we are going to see practically in our session. Okay. After that, I'll be teaching about Helm charts. What is Helm chart? How to deploy the applications using Helm chart? How it will give you an advantage, and what is the difference between the older version of Helm chart, Helm tool, and the new version. Okay. Once that is done, I'll be showing you Terraform as well. Okay. Not only the Terraform, after the Terraform, actually, we are done with the syllabus. But what I'm going to add additionally from this batch is nothing but I'll be teaching CKS exam related concepts as well. Okay, that is nothing but security. So it see CKA exam I will cover in actual course. Okay, whatever the course I'm teaching for Kubernetes, that will cover all the CKA exam related questions. Okay, you can see the dump over here. So I have the dump. I'll be sharing with you guys how to clear the exam and all. For CK exam, I will show you this. Okay. Once the CK exam is cleared, you have to be strong enough. See, in Kubernetes, you have to be strong enough in networking and security. Okay. Deploying applications, everybody can do it. Okay. So you'll get from here and there. But understanding the networking of Kubernetes, the Calico networking, and security is really important for us. Okay. So these concepts I'll be covering in depth of the networking and security. Security related concepts are like how will you security in the operating system level, cluster level like Kubernetes cluster level, and the application level. So these are the three important things for us. Okay, how will you apply your security on the operating system level? How will you apply your security on the Kubernetes cluster level? And how will you apply your security on the application level? Okay, so these are the things which we have to learn. Okay, and then we will be learning the other important thing is nothing but CIS benchmarking. Okay, so this might be new for you. Okay, benchmarking is something that let me tell you in one word. Yeah, CIS benchmarking. So CIS benchmarking is nothing but when your applications are exposed to the internet, you have to follow some particular things on your Kubernetes cluster. What should be enabled? Let's say I have one directory of Kubernetes where it is having some permissions which is wrong as per the CS benchmarking. Okay, that is a team actually which will give you some guidelines, what should be there, what should not be there, what are do's and don'ts. Okay, if you want that to be incorporated into your Kubernetes cluster, and if you want to follow the best practices of your security configuration on your system, then you have to follow this benchmarking. Okay, so this benchmarking is not only for Kubernetes, for Linux operating system, for other tools also you can use it. So we are concentrating CS benchmarking only for Kubernetes, okay, not for the operating system. So it will tell you what are the loopholes that are there in your Kubernetes cluster. So this is important for your security. Okay. So once these two concepts are done, even I will be teaching about uh, OPA, OPA policy. Where is that actually? Yeah, OPA policy, which is called as Open Policy Agent. So right now I cannot explain this about critically right now. It's a vast syllabus. So I'll just explain. And the core concept with this is really important nowadays. Okay, why? Because we are working in the current organization, we are working on Kubernetes, right? So we work on the security and networking actually. So that's the reason we will come to know what are the new concepts that should be used in your Kubernetes cluster. So OPA is one of the tool which should be used in order to have some security on your onto your Kubernetes cluster. Okay, it is kind of authorized. Okay, if it is not passing this authorization, what is the guidelines given in the OPA policy, then it will reject. It will not create a resource in your Kubernetes cluster. So that's the power of this particular tool. Okay, so this thing. Apart from this, as I told you, networking you have to be in depth on this. So I'll be teaching about Calico networking as well on this. So this is the syllabus which you don't get it anywhere actually. You can search anywhere. They will not explain everything on a single whole bunch of this. Okay. So these are the tools and these are the concepts which we are going to cover in this entire syllabus. Don't need to worry. Everything I will be showing from scratch. The only thing what you have to do is nothing but you have to complete the task, whatever I give you on daily basis or weekly basis, and you have to practice the concept what I have shown you in the class. Okay. So that you will be get you will it will register in your mind. So if you practice, so you some people might think that okay, let me listen to the whole course right now. So since it will be uploaded into the Visualpath portal, so you will think that okay, I will practice later all together once. No, it's not like that actually. Okay, so you better practice on daily basis. Spend for half an hour or 1 hour. That is more than enough. Okay, that's all the courses or the topics which we are going to cover in Kubernetes.
Hi, Sudhir. Sudhir
Hi,
Chandrakant here.
hi Chandra.
Uh, yeah. Sudhir, I just want to know, like, if I go for the weekdays class, like, what will be the duration approximately? Because currently
Oh, sorry.
I've even registered for the
45 days.
Imran's. Okay, so
45
weekdays will
days
be 45
excluding
days.
Sundays and yeah, so excluding Saturdays and Sundays. If the syllabus is running out of the time period what we have discussed, then I'll be taking on Saturday.
Okay, and like, what will be the daily duration? It will be for 1 hour or how?
1 hour only, not more than, because people will get bored. That is for sure. Okay, so 1 hour is
Yeah,
fine.
correct.
Yeah,
So, like,
because my
currently the
concept is
next ongoing.
the
Yeah,
theory
tell me,
will
sir.
be covered in 1 day, and practical session will be more in my scenarios actually.
Understood. Okay. Um, so, what will be the next batch timing, Sudhir?
You
Like
can talk to the
8:30
manager.
a.m.,
I'm not the
7:30
right
a.m.
person to decide on that
Oh,
actually.
okay, okay, fine, fine. No
Anything
worries.
related to
It's
that, you can talk to the
8:30
manager.
Sudhir, so that we can plan it actually. It start by
No, no,
9 a.m. in
see.
the morning.
Oh, okay, you are telling that now the current batch is running with 7:30, maybe 8:30 around 8:30.
Okay.
8:30
Because to
a.m.,
be
right?
frank, I'm part of Imran's DevOps class actually, 8:30 batch.
Okay,
So in
okay,
next 1 or 2 weeks, it's going to be
Yeah,
completed.
because
So
yeah,
if I want
even
to
I'm
join
the
for
part of
DevOps
that.
the
So
Kubernetes, no, I need to.
I'm just
okay. Then
concerned that it should not
see,
collide.
batch will
That's
not
what I
start
mean.
immediately, right? So we have to gather the people, we have to talk to them. So we have to know the flexible timings of them, and then we will decide. It's not that you and I should decide, right? So we have to contact everybody. So management will do that. They will give us certain, see, average time, right? Some people might be flexible at 8 to 9 or 8:30 to 9. So we'll be taking average of it. Okay.
Okay, sir. Thank you. Thank you, Sudhir.
Technically, everything
Sudhir,
you can talk to
actually,
me. So for everything, for every batch, I will be creating a WhatsApp group. So in the WhatsApp group, instead of waiting for the next day to solve your problem, you can ping your issue in the WhatsApp group itself. So I'll be solving the problem there and there itself. Okay. No need to wait
Hello.
for next day.
Sudhir,
Um,
Praveen here.
Yeah, Praveen.
Yeah. So what if Kubernetes had deprecated the support for Docker? What is the future of Docker then?
See, Docker, see, if you want to build the image, Docker is the only tool which is providing the flexibility of doing it. See, Docker should
Okay.
be there. Only
Mm-hmm.
Kubernetes has stopped the support. It doesn't mean that Docker should not be used. That's a
Yeah,
confusion where people had actually.
but
The
moreover,
problem is,
yeah.
yeah, go ahead, go ahead.
Moreover, Kubernetes, Docker is
Hmm.
mostly used for Kubernetes only, right? But in
No,
real time,
There is
no, it's not
OpenShift,
like that.
I guess.
Let me tell you. Let me tell
mm-hmm.
you. Let's say I have a Kubernetes setup. Okay. Now I want to create a container and only just a container. I don't want any other functionality, right? On that
Mm-hmm.
particular thing as well. So now I can install Docker and I can create a container. I can spin up. I can run some testing. So that's what we are doing in our production center. That's what I'm saying. Okay. So
Okay.
we are using Docker and Kubernetes. Why? Because if I want to build the image, Docker is the only tool which provides a beautiful functionalities or the options to create an image. Okay. If you look at your container D or any other tool, they don't provide it actually. There is no other option for us. So you have to
Okay.
use a Docker. You will be testing in your Docker platform. Then once a container is running properly on your Docker platform, then we will actually we will push the image to the registry, and that from that registry Kubernetes will use the image. So obviously
Okay.
you need to be working with Docker.
Okay.
Maybe
And one
you
more
will not
thing.
use all the functionalities, but
Okay.
yeah.
Okay. And how deep will go with Docker file? Because I just wanted to know. Because moreover, in real
Yeah,
time,
Dockerfile we will be using multi-stage builds. Okay,
uh
we'll be using all the options. See, I cannot tell all the options right now, but all the options we will see.